Hello, welcome back. Today our discussion will be on determination of limiting reactants in a chemical reaction. Students usually ask this question, especially in Gay-Lussac's law. I decided to make a separate video on how to determine a limiting reactant in a chemical reaction. By the end of this discussion, you should be able to explain what a limiting reactant is and determine the limiting reactant in a chemical reaction, and also calculate the amount of substance left or unused after a particular reaction. While growing up, my mom used to ration the ratio of gari and sugar. If you want to take gari, the Nigerian gari, normally she will bring one small cup in our house and 2 cubes of sugar, and say that if you have to take 1 cup of gari, you will require only 2 cubes of sugar. Though I don't like it, but I like taking sugar much. But she said no, that to keep you healthy, you have to reduce the quantity of sugar you take every time. She said, okay, that for 1 cup, you need 2 cubes of sugar. This is quite delicious because some other ingredients like milk and peanut, that's granite, are added to the mixture, and it will be very delicious. So it became like a standard. But for this particular video, I'm going to limit it only to gari and sugar, because these are the active reagents, so to say. So if you are taking 2 cups, 1 cup of gari, you'll be giving 2 cubes of sugar. So if you are giving 2 cups of gari, I guess you know how many cubes of sugar my mom will give you. So it became like a standard in our family then. So I'm going to use this concept to explain the limiting reactant. Assuming your mom came back and said, oh, what we have left is 2 cups of gari and 3 cubes of sugar. I don't know how you're going to do it, but just do it, mix it and drink. Do it the way you want, suit yourself. What will you do? To get the exact amount, or to get the same taste you have when you mix 1 cup of gari and 2 cubes of sugar, which is the standard, what do? Will you use the whole 2 cups of gari and the 3 cubes of sugar? I bet you will say no. That you will say no. I have to decrease the quantity of gari, because according to the standard, 1 cup of gari requires 2 cubes of sugar. Now we have 2 cups of gari, but only 3 cubes of sugar. So you know that when you are giving 2 cups of gari, you need about 4 cubes of sugar, right? But we have 3 cubes of sugar. So if you watch it, you say, oh no, I'm not going to use all the cups of gari if I'm to get the same, make a delicious gari mixture. I said, okay. If I'm to be with you, I said, okay, what I will do is just 2 cubes for 1 cup. Then this remaining cup, maybe I will divide it into 2 so that it can go with 1 cube of sugar. Then it means that in total we are going to use only 1.5 cup of gari for the 3 cubes of sugar. Meaning that not everything that was given to you was used. So in this situation now, the cups of gari we have is much. Like we have excess gari, but we have limited quantity of sugar. We only have 3 cubes. So in this reaction now, assuming this is a chemical reaction, the excess reactant is what? The excess reactant you say is gari, right? The excess reactant is gari. But what about the limiting reactant? The limiting reactant will be sugar, because that one is in little ratio. And it is this reactant that will determine how much of the gari you will make, the gari mixture you make. Because we have only 3 cubes of sugar. Instead of making 2 cups of gari mixture, we made 1.5 cup of gari mixture instead of 2 cups. So it is this limiting reactant, which is the sugar, that determines how many cups of garri mixture we are going to make. So the limiting reactant here is the cube of sugar, the cubes of sugar. So if this is the case, what will be left unused after mixing? After mixing the garri and sugar, what substance will be left unused after the mixture? We find out that we did not use the whole garri, we used only 1.5 cup, that is 1.5 cup. So half cup of garri will be left, right, unused. So we have a half cup of garri, which is 0.5 cup of garri, right? Okay, let's say 0.5 cup of garri will be left unused, right? Then, in what amount? Already we know it is 0.5, which is half cup. 0.5 cup will be left unused. I hope you understand. So in this situation, the substance that determines how much of the mixture will be made, mixture of garri and sugar will be made, is the cubes of sugar given to us. Okay? So that is why we say that a limiting reactant in a chemical reaction is the reagent that determines how much of the product will be made. So a limiting reactant determines how much of the product is made. And the limiting reactant is completely used up in a chemical reaction, just like we use the whole 3 cubes of sugar. So a limiting reactant is completely used up in the chemical reaction. Let's see how this is used in a real chemical reaction. Example, 0.2 mole of calcium is added to 0.2 mole of water. The following reaction occurs. Calcium plus water will give you calcium hydroxide and hydrogen gas. So according to the equation of reaction, we have calcium and water to give you calcium hydroxide and hydrogen gas. The question says, determine the limiting reactant in this reaction, and also how much of the excess reactant will be left unused after reaction. So according to the equation of reaction, we are interested in calcium and water, because what we have here is calcium and water. So according to the equation of reaction, you see that we have only one calcium here, 1 mole of calcium atom, and 2 moles of water. So according to the equation of reaction, 1 mole of calcium requires 2 moles of water molecule. But from the equation, what we were given is 0.2 mole of calcium and 0.2 mole of water. So from the equation of reaction, the standard, that's the ratio of calcium to water, is 1:2. So for 1 mole of calcium, we need 2 moles of water. Then for 0.2 moles of calcium, actually we need 0.4 moles of calcium, because the quantity of water is like twice that of calcium. If you have 1 mole of calcium, you need 2 moles of water. If you have 2 moles of calcium, you need 4 moles of water. So it's like twice the quantity of calcium. So since we have 0.2 moles of calcium given to us, what we need is twice this volume for water, which is 0.4 moles of water. That's what we need, because 0.2 times 2 will be 0.4 moles. So what we actually need is 0.4 moles of water. But from the equation, we aren't given 0.4 moles of water. What we are given is 0.2 mole of water. So from the equation, we have 0.2 moles of calcium and 0.2 moles of water. So according to the standard, comparing the standard and what we have, which one can you say is the limiting reactant? Okay, let's start from which one is in excess. We have 0.2 moles of calcium. Instead of having 0.4 moles of water, we have we are given only 0.2 moles of water. So the limiting reactant, what it means is that we are not going to use all the calcium because water is in limited quantity. So the limiting reactant is water, while the excess reactant is calcium. Are you getting me? Okay. So from here now, we can determine the amount of calcium that will be used. Since we have only 0. When you are considering the amount of the excess to be used, you go back to the limiting reactant. That will help you to know the quantity of the excess to be used. So since we have 0.2 moles of water given to us, how many moles of calcium are we going to use here? Since we know we are not going to use everything, since calcium is in excess. So what we do is, okay, we have 0.2 mole of water. So for 2 moles of water, we have 1 mole of calcium. So that is, for any quantity of water, we have half of it for calcium. So for 0.2 mole of water, we are going to have half of 0.2 mole for calcium. So what it means is that we are going to use only 0.1 mole of calcium out of the 0.2 given to us. So what will be left, the calcium that will be left after reaction, will be the quantity given to us, which is 0.2 mole, minus the quantity we used, which is 0.1. This will give you 0.1 mole of calcium left. Okay? So after the reaction, 0.1 mole of calcium will be left unused. I hope you understand. Let's try one more question and we'll stop. 30 cm cube of hydrogen at STP combines with 20 cm cube of oxygen to give us steam according to this reaction. Determine the limiting reactant and the volume of unreacted gas. If you look at this equation, according to the equation of reaction, we have 2 moles of hydrogen and oxygen. We are interested in hydrogen and oxygen. So according to the equation, 2 volume requires 1 volume of oxygen. 2 volume of hydrogen requires 1 volume of oxygen. So 2 moles, the ratio is 2:1. So since from what we are given in the equation, we have 60 cm cube of hydrogen, that's 60 volume of hydrogen and 20 volume of oxygen. If you look at this now, for 2 volume of hydrogen, we need 1 volume of oxygen. So for 60 volume of hydrogen, we need half of it for oxygen, that is 30 cm cube. But what we have here is 20 cm cube. So the one in limited quantity is the oxygen. So the limiting reactant is the oxygen. What it means is that since we only have 20 cm cube of oxygen instead of 30 that we need, it means we are not going to use everything here. So the excess reactant is the hydrogen. So the question now is, how many hydrogen are we going to use, since we are not going to use everything? So if you look at this, we go back to our limiting reactant. Our limiting reactant will determine how many of the excess to be used. So since we have 20 cm cube of oxygen, according to the equation, it is 1 volume of oxygen requires 2 volume of hydrogen. So 20 cm cube of oxygen will require 40 cm cube of hydrogen. So what will be used in the reaction is 40 cm cube of hydrogen. So, and remember, the limiting reactant will be used up, be completely used. So the reacting volume becomes 40 cm cube of hydrogen and 20 cm cube of oxygen. Are you getting it? So if you have this now, what it means is that after reaction, hydrogen, some part of hydrogen is remaining. So how many volume of hydrogen will be remaining? The given volume minus the reacted volume will be remaining. So the volume of hydrogen remaining is 60 minus 40, which will give you 20 cm cube. I hope you understand. So I would like you to try your hands on this question and see if you will get the answer. This is propane, this is oxygen. Determine the limiting reactant and the volume of propane left unreacted. Use the other formula and you get the same. Use our pattern and you get the answer. Thank you for listening. Bye.